Hello, thanks for clicking. Welcome to another Nargilus production. Today we're going to be talking about the chain rule, part one. This is one of the most important rules in the course. Okay, you really cannot continue, or you're going to have a nearly impossible time of being successful if you cannot understand how the chain rule works. It's really not a complicated thing, but I truly am being serious when I say, hey, you're going to have a really hard time with this course if you cannot understand how the chain rule operates. Okay? All right, so let's see what the chain rule is all about. Let's see what it does, and then we'll get started on actually trying to use the chain rule. Okay, so the moral of the story is we know how to derive x to the fifth or sine x. We know how to do that. We've been doing it for quite a while. But what if I want to derive 3x plus fourth to the fifth, or 3x plus 4 to the fifth, or sine of 7x? Okay, now there's a function that's inside of another function, right? 3x plus 4 is now inside of the fifth power, or 7x is now inside the sine of x. So these are all variations of these simple rules that we already know, like x to the fifth and sine x. Okay. Now, nobody wants to multiply out 3x plus 4 to, 5 times. You could do that. It's not wrong, but nobody wants to do that. So there has to be a rule for it. This has to be easier than, let's say, multiplying it out 5 different times. And it is. Okay. So the goal here is what we're going to do is we're going to derive a composite function where one function is stuck inside of another function. So in this case, f of g of x, right? So g is stuck inside of f, okay? All right, that's the goal. At the end of the video, we're going to write down the rule for what it is, okay? But first, we're going to get started by just writing the composite function f of g of x for each one of these. We're not going to derive anything. We're just going to go back, do a little algebra 2 or pre-calc, and just write down what you would have to do. So I have f of x in part A is x to the fifth, and g of x is 3x plus 4. So if I take g of x, 3x plus 4, and put it in there, so f of g of x just means find f of 3x plus 4. So that means wherever I see an x in f, I have to stick a 3x plus 4. So that would be 3x plus 4 to the fifth, right? Which is exactly what we had up here. Isn't that convenient? Okay, 3x plus 4 to the fifth power. That's what we get. I'm not asking you to multiply this out. I'm just asking you to take g of x and put it inside of f of x and see what you get. All right, so f of g of x in the second one, so g is the inside function, x squared plus 7x minus 2. And then I'm going to take this and put it inside of f. So put it in there for x. So I have the square root of x squared plus 7x minus 2. That's it. Okay, and this third one here, f of g of x. So that's going to be f of 3 minus x over x squared plus 7. So now I'm going to take this and put it inside of f, wherever I see an x. And I'm going to write 3 minus x over x squared plus 7 squared. Okay? And that's it. So we just wrote down f of g of x. Now the goal is to derive these three things. So we're going to do that in just a minute. But what I want you to understand is how you take the 1, g, and put it inside of f. G goes inside of f. Okay? All right, so that you can kind of understand that, hey, there's an inside function and there's also an outside function. Okay, so now let's go ahead and call h of x 3x plus 4 to the fifth. And now I want to find h prime of x. All right, so now to do this, we're going to use a very technical math term, okay, called blah. So what you have to remember, or what we have to say is normally we look at, hey, when we look at people and we talk about people, we say, well, you always look inside their heart first as to what kind of person they are, right? And then you worry about what they look like on the outside. It doesn't matter. Okay? All right. In the case of the chain rule, you just do the opposite of that. So basically what you do is you look at the function as it is as a whole. What kind of function is it on its outside? And then eventually you go inside. All right? So look at it on its outside first, then its inside second. So here's what I mean. We're going to use this technical term called blah. So if I look at h of x, here's what I see, and this is what I want you to see. H of x is equal to 3x plus 4 to the fifth. So to me, if I look on its outside function, what kind of function is this? This to me is something to the fifth power. We agree? Hopefully we do. This is some kind of thing raised to the fifth power. In our case, we're going to call it blah to the fifth. Okay, now what we're going to do is we're going to derive blah to the fifth power. Now you already know how to do that because that's a power rule problem. So you bring the 5 down, you leave the blah. The blah is the inside, 3x plus 4. You take 1 from the power. Now there's 4 powers left. And now the chain rule says you're going to multiply that by the derivative of the blah, by what's inside. So next to this, we're going to write d, because we're going to derive in just a second, 3x plus 4. So my suggestion is this, okay? All right, so let's just do it, and then we'll go back and do it one more time, and I'll show you how I suggest you do it. Just bring down everything you've already derived. And now the derivative of 3x plus 4 is 3. So now I can multiply 5 times 3. It gives me 15. 3x plus 4 to the fourth. And that's it. It's done. That's my answer. H prime of x is equal to that. 15 times 3x plus 4 to the fourth power. Okay? So now, here's my suggestion. This will help some of you as you go along. The rule of thumb is you can only derive one thing at a time. So let's go back and we'll do this again. I'll kind of show you how I think you should do it, at least at the start, till you get the hang of it. Once you get the hang of it, you can do it however you want. Okay? So here we go. This is blah to the fifth. Its derivative is bring down the 5, leave the 3x plus 4, take 1 from the power, times. Now come up here, cross this out. You just derived the fifth power, right? We used the power rule. That's the thing we derived. What's left inside to derive is the 3x plus 4. Okay, so that's 5. Bring all this stuff down. Don't do anything with it. The derivative of 3x plus 4 is 3. Now, come back up here. We just derived 3x plus 4. There it is. Cross it out. There's nothing left to derive up here. We derived everything. So this, we must be done deriving. And my answer is 15 times 3x plus 4 to the fourth power. I think that's the easiest way for a lot of you to do this at the beginning, is to cross out, use the cross out method, okay, as you go along. All right, so let's take a look at the next one. It's j of x. It's equal to the square root of x squared plus 7x minus 2. Okay, so now first thing we're going to do is rewrite this. We're going to rewrite it as x squared plus 7x minus 2 to the 1/2 power. So now, looking at this function is blah to the 1/2. It's something raised to the 1/2 power. So now, how do I derive something to the 1/2 power? I use the power rule. So I'm going to bring down the half, leave the blah, leave the stuff inside of it, take 1 from the power, that gives me negative 1/2, times. Now come up here, cross out the 1/2. We just derived it. We use the power rule. What's left inside to derive? Well, inside, there's still an x squared plus 7x minus 2 to derive. So I'm going to have to derive that. Bring everything else down again. We're not doing anything with it for now. The derivative of x squared plus 7x minus 2 is 2x plus 7. The derivative of 2 is 0. Okay. Now come up here. I just derived x squared plus 7x minus 2. Cross this out. There's nothing left to derive. We've derived everything. Okay, so we're done deriving. So now you could clean this up a little bit, I guess. We could write the 2x plus 7 up top. Underneath is the 2. And then the x squared plus 7x minus 2 to the half is under there. Could rewrite that. And that's the correct answer. It's done. This is the correct answer. So is this. Okay? We've derived everything. All right. Let's keep going. So here's k of x. It's equal to 3 minus x over x squared plus 7 raised to the second power. I want you to find k prime of x. So this is blah squared, right? I want to find the derivative of something to the second power. Here we go. All right, use the power rule. Bring the 2 down. Leave the blah. Take 1 from the power, becomes a 1. I'm not going to write it, but it becomes a 1. Times, cross out the second power. I just used the power rule. What's left to derive? 3 minus x over x squared plus 7. So now the question is, how do you derive 3 minus x over x squared plus 7? Well, this is something with an x divided by something else with an x. You have to use the quotient rule. So we have to use the quotient rule to find this derivative. Okay, so the quotient rule. OD high. We'll just write it out here. Minus, ID ho over ho. Okay, we're leaving this stuff all here. We're not touching it. Times, all right, we're going to leave the x squared plus 7 alone. The derivative of 3 minus x, derivative of 3 is 0. Derivative of negative x is negative 1. Minus 3 minus x. The derivative of x squared plus 7 is 2x all over x squared plus 7 squared. All right, now we can clean this up a little bit, I guess. You could distribute the negative 1, distribute the 2x. I don't know how much room I'm going to have. We'll give it a shot, though. So we got 2 times 3 minus x. I'll save that for the end, over x squared plus 7 times, all right, that's going to give me negative x squared minus 7 minus 6x plus x squared over x squared plus 7 squared. Yeah, right, because it's negative 2x times both of these. Okay, so that's going to be 2 times. All right, let me do this. I'm going to write, all right, I'll just do this all in one shot here. We got 3 minus x over x squared plus 7 times, up top, negative x squared plus x squared. They just knock each other out. They're gone. So that's negative 7 minus 6x over x squared plus 7 squared. And now these two fractions are multiplied, and that's an x squared plus 7. That's an x squared plus 7 squared on the bottom. So I'm going to leave the 2 there. I'm actually going to leave the 3 minus x and the negative 7 minus 6x there. I could multiply it out, but I'm not going to. And then that's x squared plus 7 cubed. There's 3 of them down there being multiplied. 2 from this one, 1 more here. That's now 3 of them being multiplied on the bottom. And that's the correct answer. Please keep in mind this 2 is in the numerator. There's a 1 underneath there. That 2 is up there with the 3 minus x times the negative 7 minus 6x. Okay? And now, come back up here. We derived 3 minus x over x squared plus 7. Cross it out. We're done deriving, so we're done with this problem. And I'm sure you are thankful for that. Okay, let's try it now. Let's try it, make it a little bit more complicated, I guess. So y is equal to 4 times the third root of 6x minus 1. Find dy dx. We want to find the derivative. All right. So we're going to find the derivative. Let's rewrite this first. So y is really equal to 4 times 6x minus 1 to the 1/3. And now we're going to go find the derivative. So we're going to leave the 4 out of it. It has nothing to do with it. Just leave it there. It's a constant multiplier. You can stick it in the front. Just leave it there. We're trying really to derive the 6x minus 1 to the 1/3 power. So that's blah to the 1/3. Its derivative is bring the 1/3 down. Leave the blah there. Take 1 from the power. 1/3 minus 1 is negative 2/3. Times, all right, cross out the 1/3 power. The 4, just get rid of it. You don't need it. Okay, you never needed it. You just left it in the front the whole time. what's left to derive is the inside, what was inside the 1/3 power, which is 6x minus 1. We have to derive that. So that's now 4/3. 6x minus 1 to the negative 2/3. The derivative of 6x minus 1 is a 6. Come back up here, cross out the 6x minus 1. There's nothing left to derive. This is done. And you can clean it up a little bit, I guess. You could, 24/3, that gives me an 8. Up top and underneath would be 6x minus 1 to the 2/3 power. That's the correct answer. Okay. All right, so now let's try m of x, which is x squared minus 2 times 3x plus 5 to the 6th. So these are multiplied. So now, how are we going to do this problem? Well, to do it, we need the product rule, right? It's something with an x times something else with an x. So I have to do the product rule first. Okay, so product rule says leave the first one, derive the second, plus leave the second, derive the first. Okay, so I'm going to leave the x squared minus 2 there. The derivative of x, or 3x plus 5 to the 6th. That's blah to the 6th. Its derivative is 6. Leave the blah. Take 1 from the power. Times, now we're working up here with 3x plus 5 to the 6th. We just derived the 6th power. We still have to derive 3x plus 5 next to this term being multiplied. Plus, we're coming over here now. 3x plus 5 to the 6th. The derivative of x squared plus 2 is 2x. So that was just a one-shot deal, right? There's no power up here. We just derived x squared minus 2 and got 2x. So this derivative is completely done. The problem with the first term is we still did not derive the 3x plus 5. So we have to derive that. So we have the 6 here, 3x plus 5 to the 5th. The derivative of 3x plus 5 is 3. Now come back up here. I just derived the 3x plus 5. I've derived everything in this term as well, and this term. So I'm done deriving. I don't have to derive anymore. So this is 3x plus 5 to the 6th times 2x. I'm just bringing that down. And now I can multiply. 6 times 3 is 18. X squared minus 2 times 3x plus 5 to the 5th plus 2x times 3x plus 5 to the 6th. I'm not doing any more calculus. Okay. Now, what I do want you to see is that there is a GCF here, right? 2's in common between the 2 and the 18. But more importantly, I want you to see there are 5 powers of 3x plus 5 here. There are 6 powers of 3x plus 5 here in this term. So you could factor out 5 powers of 3x plus 5. Okay? You could factor out 5 powers of 3x plus 5 out of this thing. All right? And if you did, it would eliminate all 5 powers from this term, and there'd be only 1 power of 3x plus 5 left in the other term. Okay? So I do want you to see that, because that is a possible simplification that you could see. Okay? And that's it for this one. We're done deriving it. All right, finally is the moment we've been waiting for, the derivative with respect to x of f of g of x. How do I derive one function inside of another? Okay, so now we've done it a few times. How did we do it? We derived the outside function first, left the inside function there, and then derive the inside function. And that is the chain rule. So we're going to derive the outside function first with the inside function left in there times, then next to it, multiplied by the derivative of the inside function, which is g prime of x. So the chain rule, the derivative of f of g of x is f prime of g of x times g prime x. Okay? That is the correct answer. That is the actual chain rule that you're going to work with. All right? Now, I do want to show you one more thing because I think it's important to see. We used all these rules before we ever learned this thing called the chain rule. There were a lot of rules we used, right? We learned about x to the sixth, for example. If I had a function h of x, x to the sixth, and I said, hey, I want you to derive this, we all know the answer. It's 6x to the fifth. And I never taught you the chain rule to do that. I just taught you, well, just bring the power down, take one from the power, and you're done. But here's the thing that I want you to understand. What I want you to understand is you actually did use the chain rule when you derived this. Let's take a look. This problem is blah to the sixth power. What is the derivative of blah to the sixth? Bring the six down, leave the blah, leave the x there, take one from the power, cross out the sixth power, I just derived it with the power rule, times. Now I have to derive the inside. I need to derive x. But what's the derivative of x? It's 1. So I cross out the x, and I'm done. So, since the beginning, the first rule I showed you, the power rule, you have been using the chain rule. It's just that the chain rule never made any contribution to the derivative other than a 1. It always multiplied by 1. So it didn't do anything. That's why the derivative of x to the sixth is just 6x to the fifth. Okay? The chain rule makes no additional contribution. All right? And that's how you use the chain rule. Okay? And as always, thanks for clicking.